Hi, all right. Now, why did we go over there? There we go. That's centered. Okay. Yeah. I'm going to talk to Tiny Benjamin here on the screen one more time for you today. The next question here is from Bart. Yeah, good morning, Bart. I hope everything is going all right, wherever the heck you are. So the question is this true? If so, what are the implications for finding a vaccine or building herd immunity? Thank you. And it's linked to a story on MSN. And the MSN story, if you scroll down inside of that, it's got the word study highlighted in blue. Click on that. That'll actually take you to the Nature, is it Nature Medicine? I think it's Nature Med. Yeah, Nature Medicine paper. And so that's what I'm actually looking at here. The paper is a look at the long term sort of progression of what happens to antibodies. And so we've seen some studies from earlier on in the outbreak, and this is a new set of studies. And they're looking at antibody levels in people like right after they get over COVID and then later and later and later. And what they find is that it was over 90%, I think 93 and 97%, yeah, of mild and severe COVID patients, the number of antibodies decreases pretty rapidly in the phase after you get over the illness. For some other illnesses, the number of antibodies is going to go up and it's going to stay up, or it's going to decrease very slowly. But it seems to come down a lot faster for COVID, about like that. And so, as part of this thing, kind of buried down in the paper, yeah, they did point out that for people who had mild cases, what they call asymptomatic, but of course, there's nobody who's probably truly asymptomatic. It's probably just mild cases, is the right way to think of that. And for those, they're saying that within 2 to 3 months, a lot of those have undetectable levels of antibody. Now, they're not measuring the entire immune system, but you kind of have to dissolve a person and, transfer them to various petri dishes to do that. And people, yeah, that doesn't seem like it's helping very much. So we use antibodies as kind of a thing that can be looked at cheaply and easily and quickly, and as kind of a marker for, well, how's the rest of it doing? Let's just check this part. And so we check the antibody part. That's why. Yeah, this is exactly in line with what we've seen from several other studies. This is just a newer, bigger version of that. And it's nice that it is corroborating what we had. I think the first study where we saw this was 9 patients, and then there was a study where they put together patient data from maybe 50 people, but it was just like 1 or 2 data points per person at a different time. And finally, now we're getting actual, yeah, good, solid, well-controlled data, and it is showing the same thing. Yeah, pretty big decreases in immunity, which means that herd immunity is not a thing that can happen. Or for herd immunity to happen, everybody on Earth would have to get sick at the same time, and there couldn't really be any exceptions to that. And then you'd have, your hospitals would all collapse. Yeah, everything would fall apart. And then, whatever, the survivors would pick themselves back up and get about rebuilding society. But then you'd have to do the same thing again inside of another year, probably. Or at least the people that had low grade cases would potentially be the carriers for the virus, because they could get it again and sort of incubate it through until you get to the next year, and then bam, you'd have to, and yeah, that's herd immunity is not a thing that can work for this virus in any meaningful way. Once we get to the point of like herd immunity through catching the infection, herd immunity through vaccination, you have a little bit better chance for that working, because at least you're not, subtracting a large portion of your total number of humans in order to do the trial to build up the immunity. And so potentially you can target it at the people who are at most risk for catching the virus, which would seem to be kids and working people. Kids have low percentage infection, but they're probably exposed equivalent to their adult parents. And people, yeah, that are the kids' parents' age, those are the ones that are getting absolutely hammered at the moment. Because if you're working, you are almost necessarily in contact with other people, and so you are at risk. And so it's not, you can't think of risk in terms of risk of dying. You have to think of risk in terms of risk of running into a person who has the virus and potentially catching the virus, because our goal here has to be the elimination of the virus completely from the face of the earth. And that's a thing that's going to take a lot of coordination for us to get to. So, yeah. Vaccination is going to be difficult, and if vaccines are not producing at least as much antibody as you get in people who have recovered, then vaccines are not going to give you more than 2-3 months protection. Yeah, that's just the way it is. And a lot of that's probably determined by a person's genetics. You may have a great vaccine, and it's only going to work in some people and not in others. So, yeah, we cannot wait for a vaccine to start tackling this virus. I think that's what a lot of people who are maybe disregarding the restrictions or just going out and living for today, I think in the back of their mind, they're thinking science is going to, find a way, and we're going to solve this thing. And then I'm going to be the one who is out just having a decent time and not sitting at home worrying about it or wearing a mask, which is uncomfortable. And yeah, that just doesn't work. There's no we can't rely on that, because if we do, we're going to have this virus forever. We can still turn this thing around, but just with public health, with mask wearing, basic mask wearing, and don't congregate. And that'll do it. And when it's that easy, when it's that blatantly, easily obvious, it kind of makes you wonder why everybody doesn't just do that. I know people have their reasons. Good Lord, yeah, I've heard a lot of their reasons, and they're all, masks are okay for you, but not. I'm not gonna wear one, but I understand. Yeah, but oh my gosh, yeah, that's how we got into this mess. That's why we're in this mess. That's the thing that has to change if we're gonna get out of this mess. Unfortunately, I wish there were another way that didn't have to involve most people, but this one is going to have to involve everybody if we're going to get out of it. So there we go. Yeah, sorry, Bart, that was a downer, but but it's good that you brought up this paper. This is one that I had not seen on the preprint server, so it's one where they just actually published it instead of putting it out there for people to look at before it was published. And I missed some of those, so thank you. When you bring those to my attention, this helps. Yeah, thanks very much. This has been Ask Dr. Ben, and please just wear a mask. It'll be all right. Thank you very much.